Welcome our dear students, with you Mr. Ibrahim الدسوقي, first secondary, first term about algebra. Pre-requirements on Unit 1. We studied before solving quadratic equation algebraically and graphically. For example, find the solution set in R. R is a real numbers algebraically. Okay. First one, 3x power 2 plus 5 equals 8. We want to find the x and we want to x to be alone in its side. Then 5 go there, minus 5, 8 minus 5 equals 3, divided 3 equals 1. Therefore, x power 2 equals 1 and it takes the square root, therefore x equal positive or negative 1. Another one, x power 2 plus 5x plus 6 equals 0. You can factorize it. Why? Because we have two numbers, their product is 6 and the sum between them equals 5, which is 2 and 3. Then we can factorize it. X plus 2 times x plus 3 equals 0. Therefore, x equals negative 2 or x equals negative 3. And you can use the calculator mode equation 3 to get it. The third one, x power 2 minus 2x minus 6. I haven't two numbers, their product is 6 and the difference between them is 2. Then you should use the formula. By using the formula, negative b positive or negative root b power 2 minus 4 ac all over 2a. A here equals 1, b equals negative 2, c equals negative 6. By substituting, put b here, negative 2, negative times negative gives me positive. Here, negative 2, all power 2 between brackets to gives me 4. And so on, substitute, gives me the result, x equals 1 plus root 7 and 1 minus root 7. We have two roots or two solutions. Example, find the solution set in R graphically. X power 2 minus 2x minus 3 equals 0 using the interval from negative 2 until 4. Then the values of x is negative 2, negative 1 and so on until 4. You can use two ways by substituting, put negative 2 instead of each x, okay, and the negative 1 and so on until I reach 4. The second way by using calculator. Press mode, after that table, write x power 2 by using alpha, x power 2 minus 2x minus 3, start here is negative 2, end is 4, and the step always equals 1, okay, to get the table which we have. The first point, negative 2, 5. The second point, negative 1, 0. The third point, 0, negative 3. Here, negative 1 and 0 lies on x-axis because negative 1 for x. Here, negative 3 for y. Therefore, the point 0 and negative 3 lies on y-axis and so on. You can draw the curve. To find the solution set graphically, look at the intersection between the curve and the x-axis. We have two solutions which are 3 and the negative 1. Again, to get the solution set graphically, look at the intersection between the curve and x-axis. Then we get the solution set is 3 and the negative 1. We have three cases. If the intersection between the curve and the x-axis at 2 points, then we have two solutions. If the intersection between the curve and the x-axis 1 point, then we have one solution. If we haven't the intersections between the curve and the x-axis, then the solution set here equals phi in R. Okay. After that, we have the solution set in complex number. Example, We want to find the solution set in each figure. Here the intersection between the curve and the x-axis is -2. Therefore, the solution set here equals -2. We have only one solution. Here we haven't any solution because we haven't intersection between the x-axis and the curve. Therefore, solution set here is phi. The intersection between the curve and the x-axis, we have 2 points which are -3 and 1. We have 2 points. The 3 cases, 1 point, 2 points, 0 points. Lesson number 1, an introduction in complex numbers. Okay, before studying the complex number, we must know the imaginary number. We know that when x power 2 equals -1 has no solution in R. Why? Because x here equals positive or negative root -1, and the square root of -1 doesn't belong to R. Okay. Okay, therefore, root -1 denoted by I. I is the imaginary number. Imaginary number is I equals root -1. Therefore, I power 2 equals root -1 times itself gives me -1. This is the first time power even gives me negative. I power 3 I times I power 2. I power 2 equals -1 times I gives me -I. I power 4 equals I power 2 times I power 2, -1 times -1 gives me 1, and so on. It's a cyclic. I power 5 gives me I. I power 6 gives me I power 2. I power 3 gives me I power 3, which is -I, and so on. I power 8 equals 1. I power any number divisible by 4 gives me 1, such as I power 4 equals 1, I power 8 equals 1, I power 40 equals 1, and so on. Okay? Put in simplest form. Here I power 80. 80 here is divisible by 4 equals 1. I power 30. 30 here is not divisible by 4. Then divide 30 by 4 and take the remainder. The remainder here is 2. How? As we studied before in primary. 30 is not divisible by 4. Reduce 30. Take 29. 29 is not divisible by 4. 28 is divisible by 4. 38 minus 28 gives me 2. Then the remainder is 2. Put the remainder at the power. Okay? I power 2 in simplest form, as we said, equals -1. I power 19. 19 also is not divisible by 4. 18 is not divisible by 4. 17 is not divisible by 4. 16 is divisible by 4. Then the remainder here is 3. Then we have I power 3 in simplest form is -1. The simplest form I or -1 or -I or 1. Another example, I power -10. -10 is not divisible by 4. The number which is less than -10, of course, the -11 is not divisible. -12 is divisible. Then we have 2 the remainder. I power 2 in simplest form equals -1. 1 over I power 11 equals, as we know, I power -11. -11 is not divisible by 4. -12 is divisible by 4. Then the remainder is 1. Its simplest form equals I. Complex number. Complex number consists of 2 parts, real part and imaginary part, and we can't simplify it. Okay? Examples for complex numbers. As we see, 2 minus I, 2 is a real part, -I is imaginary part. Also here 7 plus 13I, real part and the imaginary part, 5I minus 4, and root 2 plus root 3I. All of them are complex number, and each of them we can't simplify it. It is the simplest form. Example, find x and y if number 1, 2x plus 1 plus 4y I equals 5 minus 12i. We have 2 complex numbers are equal. Therefore, real part equal real part there. The imaginary part here equals the imaginary part there. Therefore, 2x plus 1 equals 5 and the imaginary parts are equal. 4y equals the negative 12. Therefore, 2x plus 1 equals 5. 2x equals 5 minus 1 equals 4. Therefore, x equals 4 divided 2 equals 2. Also, 4y equals negative 12. And y equals negative 12 divided 4 equals negative 3. Second one, 2x minus 3 plus 5i equals 7 plus 3 minus 2y. Also, real equals real, and imaginary part equal imaginary part. Therefore, 2x minus 3 equals 7, and 3 minus 2y equals 5. 2x minus 3 equals 7, therefore 2x equals 10, and x equals 10 divided 2 equals 5. Okay. 3 minus 2y equals 5. 3 go there, minus 3. 5 minus 3 equals 2. Negative 2y equals 2, and y equals 2 divided negative 2 equals negative 1. Real equal real, and imaginary equal imaginary. Therefore, 2x minus y equals 5, and x minus 2y equals 1. The coefficient of I here is 1. Okay? Therefore, we have two equations in two variables. Okay? We can get the answer by using calculator. Mode equation 1. Then we get x equals 3, y equals 1. So, if we want to do steps, okay? We are going to multiply the equation number 2 by negative 2. X times negative 2 equals negative 2x. Negative 2y times negative 2 gives me 4y. 1 times negative 2 equals negative 2. And add this equation with number 1. 2x with negative 2x cancelled. Negative y with 4y gives me 3y. 5 plus negative 2 gives me 3. 3y equals 3, therefore y equals 3 divided 3 equals 1. By substitution in any equation, therefore x equals 3. Example, we want to simplify two complex numbers, add them and multiply each other. Here we have two complex numbers, 7 minus 4i plus 2 plus I. You can use the calculator 570 or more. Press mode. After that complex, you can use it to operate any two complex numbers. Okay? But we want to know the steps. Why? Because sometimes the calculator gives me error. Here 7 minus 4i plus 2 plus I. Add the real parts and imaginary part. 7 plus 2 equals 9. Negative 4i plus I equals negative 3i. B, we want to multiply it. 2 plus 3i times 3 minus 4i. Multiply 2 by the second bracket, and 3i also times the second bracket. Distribute 2. 2 times 3 equals 6. 2 times the negative 4 equals negative 8i. 3i times 3 equals 9i. 3i times negative 4i gives me negative 12i power 2. And we know that I power 2 equals the negative 1. Negative 12 times the negative 1 gives me 12. Or we can say, cancel I power 2 and change the sign. Okay? Simplify the real parts and imaginary parts. 6 plus 12 equals 18. Negative 8i plus 9i equals I. Conjugate numbers. What is the meaning of conjugate numbers? A plus bi is a complex number. Its conjugate change the sign of imaginary part. Then a minus bi, its conjugate. For example, 4 minus 3i and 4 plus 3i are two conjugate numbers. When I'm going to multiply any complex number by its conjugate, gives me real number. And also when I'm going to add them, gives me real. As 4 minus 3i times 4 plus 3i gives me the final 25 real. And when I'm going to add them, gives me 8 also real number. Example, we want to find the result of each one in simplest form. 4 plus 3i times 2 minus 5i. Number 2, two conjugate numbers when I'm going to multiply it. And the bracket power 2 and the bracket power 4. 1, we did it. Distribute, and the final answer gives me 23 minus 14i. Number 2, 5 minus 2i times 5 plus 2i. Two conjugate numbers we studied before. When I'm going to multiply a plus b times a minus b, multiply first times the first and second times the second. Also here, 5 times 5 gives me 25. Negative 2i times 2i gives me negative 4i power 2. Cancel i power 2 and change the sign gives me positive 4. 25 plus 4 equals 29. Bracket power 2, we know that bracket power 2, first power 2, second power 2, first times second times 2 and keeps a sign. Here 3 power 2 equals 9. 2i power 2 gives me 4i power 2. First times second times 2, 3 times 2 times 2 equals 12i. Okay, I power 2, cancel it and change the sign gives me negative 4. 9 minus 4 equals 5 plus 12i. Drop as it is. 1 minus I all power 4. We can't expand it, and if do it at calculator gives me error. Then 4 equals 2 times 2. 1 minus I power 2 all power 2. We can get 1 minus I power 2 by calculator or by steps as we did. Gives me 1 minus I power 2 gives me negative 2i all power 2. Distribute 2, negative 2 power 2 equals 4. I power 2. I power 2 negative 1. 4 times negative 1 equals negative 4. Example. X equals 7 minus I over 2 minus I. We have imaginary part in the denominator. Then you must remove it. How? By multiplying the conjugate of the denominator up and down. Also here, we must multiply the conjugate of 4 plus I up and down. And we want to prove that x and y are conjugate number. After that, prove that x power 2 plus y power 2 equals 16. Okay, here multiply each of the numerator and denominator by the conjugate of the denominator, which is 2 plus I. Distribute, and we did the steps before, gives me the final answer 3 plus I. Y also multiply by the conjugate of the denominator. The conjugate of the denominator here is 4 minus I. Multiply it up and down and simplify gives me 3 minus I. 3 plus I, it's the conjugate of 3 minus y. Therefore, x and y are two conjugates. We want to prove that x power 2 plus y power 2 equals 16. X power 2, 3 plus I all power 2 gives me 8 plus 6i. Y power 2 also. Then we get x power 2 plus y power 2. Simplify it to get 16. Another example. Find the solution set in the set of complex numbers. In real numbers, root negative 1 has no solution. But here in the complex number, we have a solution. 2x power 2 plus 18 equals 0. Therefore, 18 go there. Negative 18 divided 2 equals negative 1. Negative 9, sorry. Therefore, x here equals positive or negative root negative 9. Root negative 9 equals 3i. Root 9 equals 3, and the negative under the root gives me I. As here, x equals positive or negative 3i, then the solution set is 3i and negative 3i. Number 2, a equals 1, b equals 1, c equals 1. We can use the formula and substitute on it. b equals 1, a equals 1, and c equals 1. By substituting gives me the result negative 1. Positive or negative root 3i over 2. We prefer to separate it. Imaginary part and real part. It gives me negative 1 over 2 plus root 3 over 2i, and the negative 1 over 2 minus root 3 over 2i. Thank you. Good luck.